Good morning, everybody, and welcome back to our Powermetrix series. Chris Mullins and I are here in the bunker this morning, and we'll be talking about theft, tampering, and troubleshooting, and that we have to deal with out there all the time. I will say before we get started, we got a little unsettling news this morning about a dear friend of ours, Powermetrix. We've known him for 15 plus years. When that happens, you're much more than customer and supplier. This person was a friend of ours. And we just got some bad news that he's in hospice now with cancer at home and not doing very well. So we're obviously going to pray for him this morning, and also going to pray for what's going around the country and pray for everybody else today. So let's go ahead and pray first, and then we'll get rolling on this thing. Precious Heavenly Father, when we hear news like that, these are the times that we seem crazy to the world as Christians, because finding out that this brother of ours is saved and a Christian definitely takes the edge off of it. We hate it for his family. We hate it for his friends. They're going to miss him. But Father, knowing he's going to spend eternity in heaven helps us deal with it. And Father, I lift up our country right now. Seems like what's been going on has not come to an end. We actually have anarchy in our country and everything else. And Father, I keep putting my faith in the fact that there are a lot of people praying right now, even people that say they aren't Christians. And so, Father, I hope there's a revival in this country of people turning to you and treating each other with respect and love, as we're taught in the real Constitution, which is the Bible. And Father, thank you for all these things, and thank you for what you're doing for us. And as we said, we lift our brother up. And Father, most of all, thank you for Jesus. If he didn't do what he did, I couldn't even pray right now. So, Father, all of these things I ask, and I say, according to the will of the one who paid it all, my brother, Jesus Christ. Amen.
Amen.
Cool. You clicking or I'm clicking?
You're clicking.
Oh, Lord. Okay, I'm clicking. Should have never done that. All right. COVID-19 quarantine webinar series. Man, that's long. Today we're doing theft, tampering, and troubleshooting. As you saw earlier on Tuesday, we're going to, next Tuesday, we're going to do effects of power quality. Next Thursday, we're going to do a metering Q&A forum. I won't be on the Tuesday one because that's more brain power than I have, but I will be involved in the one on Thursday in case they just need someone to just say something they've seen out there in the field. So
Yeah,
I will be involved.
Thursdays will be an interesting one because we kind of be some quote-unquote resident experts.
Yes.
So we'll be able to have the guys, send us questions, and I'll have some topics of interest. We'll kind of get the conversation started, but I wanted to kind of have a round table where you guys can actually ask questions that you may have been asking or wondering about, and maybe we can help answer some of those.
Absolutely. And so we'll have, and just like Chris said, we'll have a cross section there. We'll have field, we'll have engineering, we'll have the design, marketing, we'll have all the folks there. So we'll have all the folks there so that if you've got something you want to talk about, this would be the crew to talk with about it. So we can give you answers, and maybe you'll give us some great ideas.
Sure.
Hopefully. So.
Go ahead and email those questions in now, or put them in the chat box now.
Nice. There you go. So send those in so we can be looking at them and maybe prepare a little bit for them. So please send us in some stuff, all right? Cool. So the agenda for today, we're going to talk about technical versus non-technical losses, the impact of theft, different types of theft and tampering, tools for detection, and we'll actually run some examples here live using the benches to go over some of the types of tampering and what you see with the equipment when they have tampered with it. Okay, so what you can detect and not detect, and which is, me, I'm always wanting to get it down to the field part of it of, okay, but what about when I'm standing there with the equipment? What happens? So.
Yeah.
So let's talk about electricity losses. You can divide them into technical and non-technical if you want, which we've done here, which we're talking technical are the things that the utility company really doesn't have that much control over. THD, total harmonic distortion, unbalanced loads, resistance, you're talking about between, in the CTs, you got iron losses. All these different losses, a lot of them the utility really doesn't have that much control over on doing anything about those losses.
Right.
Yeah.
Good news is that a Power Master can take both technical and non-technical losses.
Yes, absolutely. So because you know that ours has a total harmonic distortion on there, and you can, the harmonics is on there. We go up to the 50th and the 100th harmonic, so we can detect the harmonic problems. So exactly what Chris is saying, we can handle the technical. Today we're going to get over here on the right side and talk about the non-technical though, which is, the wrong multiplier in there, which you remember back if you've been to any of the meter schools, you've seen where we've run and we're going to use some of it here, where you've seen if the wrong multiplier is on there, that's one of the big hits. Okay, that's where it's big numbers are affected. Wiring errors, where we, polarity reversal, or we wired something wrong. And today we're going to concentrate on that third one, which is theft and tampering. Okay, so that's what we're going to talk about today.
Yeah, we don't spend a lot of time on theft.
Nope.
I mean, kind of like I've been with the company for 19 years, and we mostly focus on that non-technical stuff.
Yes.
Finding those wiring errors, finding the administrative errors, but we haven't really not. We looked through all my stuff, and there wasn't a lot we had talked about for theft. And so, as I was doing my research, I got a lot of interesting information.
Nice. There you go. And this was part of that I talked about earlier. If you've been to any of the meter schools and seen it, it's one of the presentations we have in these next slides here. This is actually from a large municipal here in Tennessee. And when we ran it, you can see here, we looked at what the different errors were out there, and we divided up and found out where all the errors were and where the losses were. And we said, so what represents what percentage of the losses overall? So if you were trying to guess what these numbers represent, wiring errors, you can see there's 19%. PT problems, you see there's 7. Administrative errors, ooh, that's those billing multipliers, right?
Big one.
37%. Faulty meter, problem with the meter, okay, that's 19%. CT problems, okay, those are 7. So the CT and PT problems were the same. And then theft of service, 11%. So if you look at it between theft of service and administrative errors right there, man, you're at 48%. So it's big. So when we ran this thing and used it, we found that we can separate it out and tell you where you need to really concentrate. I mean, if you're looking at the numbers, and we're talking about revenue right here and bigger customers, where would you concentrate, your, so to speak, where you're going to look for it, where you're going to try and bird dog it and see where you can find your problems. And we can see where the biggest ones are right here. And when we did the study there at the municipal, we tested 35,000 TR rated meters. And you can see there we found 11 problems were found with theft or tampering. And the total revenue loss was $247,318. So each one of them averaged $22,483.
That should give an idea, especially utility management, what kind of impact this really is.
Absolutely.
And I was surprised myself when
Yeah.
I started looking at this information.
Oh, absolutely. And then you start multiplying by how many you find a year. And so in United States, they have, we found the theft statistics here, $6 billion of electricity stolen each year. It's up to 2% of all electricity generated is stolen. And it's most common in residential and small commercial services. And then loss of revenue, of course, causes pressure for utilities to raise rates. I mean, I know of some that I've heard stories out there where that's really, you hate to hear it, but they'll actually raise the rates versus getting out there and trying to test and find the problems. It's just an easier route, but man, does that cause problems both ways. That's going to make everybody unhappy.
Yeah.
Okay.
Customers mad. Now I've got to try to go through that battle, the PUC.
That's
Go
right.
through that. It's a rigmarole. Is what it is.
Yeah, it is. And when you were looking at this stuff, didn't you see that as far as when we're saying 2%, in the United States, though, there were some staggering numbers around the world. Right?
I know it sounds incredible to say 6 billion, which translates to 2%, but in India, which is the #1 country for theft, 30%. 30% of all the electricity generated is lost in theft.
That's crazy.
That's an astounding number.
That's crazy. 30%. And here's some actual stats that we've got from back in 2008 with the economic downturn.
Something happened in 2008.
Something went on there. Yeah. Any homeowners can tell you. But yeah, everything went crazy. Yeah, Jared's raising his hand. Yeah. So during that time, we have some utilities that gave us some interesting numbers here. PECO up there in Pennsylvania, they had 30% of 14,000 customers whose service was disconnected were using it illegally. All right. PP&L in 2008, because remember there's a lot of people being turned off in 2008, reported 16% rise in energy theft. And then AEP in February, they had 27% increase in energy theft. So Mullins has got a good point here. With our recent economic downturn, will this trend return? We know that from some of our utilities that we talked with, and I think we have a slide on this about the COVID.
Yeah, further out.
Oh, is it further? Okay. And we'll talk about that in a minute because we're actually in the midst of something right now ourselves, as we all know. So we'll talk about that here in a minute. So how that's going to affect us. And it already has because of some of the guidelines that they've given and some of the marching orders they've given the folks as far as treating some of these customers out there. And we'll cover it here in a minute.
Well, you've got, and here's a fact. You have one of the highest unemployment rates right now in the country.
Absolutely.
There is no doubt in my mind this is going to start to affect theft.
Oh, absolutely.
For sure.
Yeah. I mean, look what happened in 2008.
Yeah.
And we didn't have that much. So, yeah. So meter tampering. So it's using methods to slow down or bypass the meter. And you can go back to and everybody's got stories. When you start talking about tampering, everybody's got stories. And I've heard bunches of them. The pine needle stuck through there where it's dragging on the disc as it's turning. Or ants. Put some honey in there. Get the ants on longer. Yeah, we've heard all the stories. Well, and that's what you do. And here's some examples right here. The one on the left, they're using a magnet to slow the meter down. Okay. And then you can see you can also bypass the meter, which people do that. We've got pictures of that coming up. You've got a remote switch. I can tell you when I was down CFE down in Mexico working with them, one day I was down there in the offices and this guy came in and they just about were carrying him on a chair, guys, and cheering for him and everything. And I was like, wow, what's going on? And they said, man, Jesus found a huge theft out there. And I said, really? So after a few minutes, they allowed me to take a look at it. And what they had actually done, they had inserted 3 little bitty circuit boards in that meter, and they had a remote switch so they could turn that meter on and off, or each individual phase on and off. So when the meter guy was coming around, we turned it back on, but they were turning either turning phases off or all 3 at the same time. And this was for a huge, now think about where I'm talking about, Mexico, a huge ice plant. It was also connected to that huge ice plant was actual refrigeration themselves. So it had a big, huge refrigeration and then an ice plant all connected. And remember the conversion rate, pesos, $2, the number was staggering. And so people get pretty creative on stuff like this.
Yeah, from what I found, sometimes these things can vary from a very, very simple
Yes,
to very complex, like what you saw in Mexico.
exactly right.
That's like almost an industry on its own, right?
Yes, it
That
is.
somebody in their garage is making these and selling them
That's right.
to these companies. That's astounding.
Oh, seriously? Well, I remember years ago being at Glimpse up in Michigan, when the guy comes in and does his theft presentation. There was a guy advertising. He was running after the Power Doctor, and he said he'll come and drop your bill. And he was going out there and he was advertising on Craigslist and stuff. I mean, he's
Wow.
out there. Yeah, I'll come drop your bill. Just give me a call. It gets crazy. And then inserting a foreign object into the meter, you can see over on the right-hand side, they've just shunted across there so that now they pull the meter out and now it just runs straight through. There's no meter there to run through, so they're not going to get billed, but they're going to get power. That one's pretty obvious when you walk up. Then one of them is, one attempt is rewiring. And the one on the far left is similar to what I saw up there in Michigan that time. He had showed where people had used jumper cables like that.
Yeah.
Yeah. So all they're doing is they're just rerouting it even from a neighbor, pulling off a neighbor's service and rerouting it over to their house so that the neighbor's paying for their electricity.
Yeah, and the one in the middle is a commercial site. So what they've done is they've actually pulled off the line coming off of their neighbor's meter and then sucking that off right into their system.
They called the Power Doctor.
Yeah, the Power Doctor.
And he went up there because that is serious. Now, you hate to say it, but there's got to be some retired linemen somewhere that are doing work for people because, man, you just don't jump up there and do stuff like this.
That's what's so amazing to me is that, as this stuff gets more complex, you're going to have somebody who's got experience.
They've got to have skills.
Where are they getting that experience?
That's right. They got to
Good
have
question.
skills or they're
Yeah.
not going to make it. And then the one on the right over there, you can see where over there, if you're going from left to right across the top, my lug, so I got A, B, and C phases. You can see there where they took A phase and just ran it all over on the neutral over there on the far
I
right.
believe it's the 12S meter, I think is what it is. So basically when they move that phase to neutral, they just take it one phase away.
There you go. This one's interesting. So when thieves install their own transformers to steal large amounts of electricity from the grid undetected, examples vary from simple to very complex. When I see this, I think grow operations. Because I know they will literally tap off the pole, they'll even change transformers, relabel them, and then they will run it underground and come up to the grow operation and they'll have their own transformer.
You're talking about marijuana grow.
Yes. Yeah,
Gotcha.
yeah, sorry. Yeah. And so on these grow operations, that's what they'll do. They'll run it underground. I've had guys tell me that out in the field. And unless you see the transformer or anything or really inspect up there on the pole and look at those transformers, you wouldn't know.
Yeah.
Yeah.
In this case, this was a grocery store, and they had somehow tapped on to the high side and actually ran through their own bank of transformers and hook up to their service. And the utility actually caught them. And when they came to them about to put them in jail, they said, "You can either go to jail, or you can write me a check for how much you've lost." And the customer decided to go ahead and write the check, and he got out of trouble. So
Yes,
you caught me.
You caught me. Yeah, I think at that point that's probably the right
Yeah.
thing to do is write a check. Yeah. Check, jail. I'm going check. But it's amazing, and it seems that, and to Chris's point earlier, when times get tougher, people seem to get more inventive, and they also get more brave, and so they do crazy things. I can remember being Detroit Edison, working up there, a different company. I'm up there working with Detroit Edison back when the copper blew up and copper started becoming so expensive. And man, people were getting killed, busting into power transformers or just trying to dig up underground lines, and they were getting killed. They would find melted tennis shoes, people blown out of their tennis shoes because they were just trying to sell that copper. So people can get pretty brave. Kind of mentioned it earlier, unpaid bills. People have had to change their operating procedures now, their SOPs, because of what we're in right now, the COVID-19. So you can see here, there's refusal or negligence on paying the bills, but, and I love this next line, ranges across all socioeconomic individuals. Yeah, don't think it's just the PO folks. It's not just the PO folks. Don't think it's just the PO folks, because it's
rich
not.
people try to get out of it as well.
Oh yeah.
Even though they got money, they still try to figure out a way to get out of it.
And if you catch them, they'll tell you, "How do you think I got rich?" That's how I got rich.
Yeah.
So policy changes from COVID allows customers not to pay. A disconnection by utilities halted. Talking to utilities here over the last few months, they've had to put this into effect, and so I think this is going to raise up a whole new, what would you say, wave of creativity, so to speak.
Yeah, because right now they've gotten a green flag, right? They can do whatever they want. They're laughing at the utility at the moment.
Yes.
Those who are stealing. Now,
Yes.
those who are actually going through a real problem, it's good for them. But there are people that are taking advantage of this.
Oh, absolutely.
Oh, now you can't touch me. Then you can't cut me off at all.
Get out of jail free.
Yeah.
Solutions to theft. Remember, we had the non-technical and technical that was laid out in the other slide. The non-technical, community outreach, rewards for those who report theft. You'll see the stickers and everything, report, call, whatever, and you can report somebody. Stricter fines, process improvement. Post-inspection for a site that was disconnected, never reconnected. That's an interesting one if you think about it. So you go and disconnect somebody, and a lot of times we think out of sight, out of mind. I've disconnected and we move on.
Right.
But what if someone comes back behind there and is stealing the power or tapping it off? And they could be tapping off their neighbor's power and run over there and still living in a house with no power. It could be hanging out. So, there's probably that'd be a good thing to put into your process, that maybe after you've disconnected someone after so many months, just run back by there and make sure everything's okay.
Right. Yeah. And I found out most utilities do not do this.
No.
They do not have any kind of flag in their system that says go out 3 months, 6 months, 9 months later to determine to see if
That's right.
they're stealing.
Then the technical ones we talked about earlier when we were talking about the THDs and the resistance stuff. You can encase the meters, anti-theft cable. I like to tell the story on the anti-theft cable. I'll let you tell me.
Yeah, but basically it's basically a bike theft cable that goes around the meter. Funky.
So it's just like putting your bike in the rack and you lock it down.
Yeah.
That's funny.
In the combination, you need the combination together.
So you can,
1, 2, 3, 4, 5.
That's right. So you can have an anti-theft cable bicycle lock. If you want to put that on there.
Yep.
End of line monitoring, usage monitors, and then those are more old school technology versus what we're doing now, as everybody knows, implementing AMIs and putting in and installing the smart meters.
Yeah, they're using this a lot, just trying to get around these. Now, I mean, the good thing about AMI, it can detect a lot of stuff.
Sure. And here we talk about that, AMIs. So there are pros and cons with it. The pros are an AMI or smart meter can identify usage on inactive meters or quick drops in demand. So if it sees a problem at the meter, if it sees a drop in usage, or it go to all of a sudden zero usage, it would say, whoa, 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 but it would flag it and say something's going on.
Yeah, let me be clear. It looks for a significant drop in usage.
Yes, good point.
It's not always looking for a trend.
Exactly. And then voltage drop detection can help detect bypassing the meter. If people try and bypass the meter and they see the voltage drop, then they would realize there's a problem there, and AMI would let them know something.
Sort of.
Sort of.
Another way to look at that is if they could be misconstrued as a power outage.
Yes. And then remote disconnect helps the customers not paying the bill, so they can remotely disconnect.
Yeah, that's true.
But to what Mullins was saying earlier, we always talk about this. What these systems are looking for is a big spike up and down, or all of a sudden it goes to zero usage.
Yeah.
But we've also, and there's a lot of you out there that'll be nodding your head, there's been situations where, though, if that meter thought that this was the correct usage from the start and it didn't change and I didn't get a spike, no flags would go up, no alarms would go up, so no one would be sent out, and the customer is still underpaying drastically for their electricity, okay? Now the cons, just what we said, a smart meter can only detect problems at the meter. It can't tell you what's going on at the CTs or the PTs. And then you have false tamper alarms are commonly ignored. Think about how many times when people first put a system in and they're getting all those crazy
Think about the new
alarms.
construction.
Yeah, new construction, they're going, man, yeah, we'll get to that, because you kind of think that's just part of the installation of the system. Well, it could actually be some tampering going on. It's a theft. And then it cannot detect rewiring, right? Because this meter sees garbage in, garbage out. Meter sees what it sees, right?
Especially when, and again, I'll go back to what we said before. If it's not a gross drop or a gross increase, like a marijuana growth,
Right.
then it's probably not going to detect it unless it's doing some kind of trending.
Mm-hmm.
So a rewire, if they just, let's say, moved a phase over, it would just look to be a small drop in current. So therefore, the thief wins because the utility never saw it or never really looked for it,
Right.
and they're getting less bill. Maybe not 100%, maybe they're getting 50% less.
Right. But because, just to what you're saying, let's say they only cut 10 or whatever off of it, that's not enough to flag.
Not enough to flag.
There you go. Cool. Then it cannot detect illegal transformers. Okay, so when you put in all your own transformers and you run all your own circuit, that meter has no idea.
Obviously.
Yeah, it doesn't know what's going on. It's just reading what it's reading. So now we're going to talk about using the PowerMaster as a tool to detect something, or maybe not detect, but maybe, let's see, the best way to do this. Remember, we always talk about being forensics guys out there. We got to use our eyes, we got to use our heads a little bit, and then also use the equipment. So all of this is used when it comes to trying to detect theft or tampering. Okay, because some things are visual, that when you walk up, you go, whoa, I see something's wrong, and some of it will pop up on the equipment. So here's where we have to use all of our skills to try and detect some of this stuff, okay?
Yeah, so the first one we're going to talk about is this is an actual theft where the customer has actually taken the meter out, somehow gotten the meter out, flipped it up, and then plug it upside down. And so we're going to kind of show what that does. I'm going to run over and start the bench.
All right. And if y'all could see it, I am pulling my gloves out of my bag, fingers first. They are in my bag correctly. What's that? Oh, the chats.
Go to that.
Who's quicker?
Where's the mouse for this?
Oh. Ah. This is the mouse.
There you go. All right, you ready?
Yep.
All right, so John has just walked up to this 2S residential site.
Yep. So I walked up to this 2S residential site, and using my eyes and my head a little bit, I'm looking at what would be one of the first things I would notice. That the meter is upside down.
Duh.
That one's where if we use our eyes just a little bit, think a little bit, that one jumps out at you. So someone has inserted this meter and they're upside down. And why would they do that? Well, what do you think is going to happen when they do that?
And what's going on? If you're looking at the register, what's going on there?
Yeah, so if you look at the register, which way is my worm going? Worm's going the wrong way, right? Now let's look at the test. What would you think would happen when you test it with the Powermetrix kit? Would you think this would jump out and give us something so we'd say, uh-oh, there's a problem? Let's take a look. Wait a minute. Why isn't it? It's telling me it's giving me a good positive number.
Yeah,
It's
so I've
not-
taken our Powermaster, I hooked it up. Everything looks okay.
Yeah?
Why is that?
All right, let's think about this for a second. My Powermaster is hooked up here to pick up my currents, right? So when it's picking my currents up, my currents are still flowing the correct way. So when these clamp-ons pick up that current, they're picking the current going in the correct direction. Okay, they're not seeing on the backside of me, they're just picking up what's going through this wire right here. Okay, and where I make my connections here and here on the voltages, nothing's changed there. Where the change is right here with that meter being in there upside down. So the Powermaster is going to see everything as being okay, and it's going to give me a positive registration. Now, what if the meter wasn't bidirectional, Chris?
Yeah, if the meter wasn't bidirectional, let's say a mechanical meter with a detent, that meter wouldn't turn backwards at all.
That's right.
Now, no matter what, I believe if this was an AMI meter or a smart meter, that you should get an error on your system because you get zero consumption.
Right.
Meter's powered up, that shows up as good, but there is zero consumption because the meter's turning backwards. Question I would have, which I don't know the answer to, and maybe our guys in the chat would know, for utility, would this ever be considered a bidirectional meter, like a renewable site meter? Could this ever be misconstrued as that?
Gotcha.
Whereas negative registration, the meter's turning backwards, would the utility ignore it and just assume that it's, oh, well, it must be a renewable site?
Right.
That question I don't know.
Yeah, and when we were talking about that earlier, something popped in my pea brain. I was thinking, well, what if someone residentially has solar panels up there? So if a residential customer's got solar panels up there, and all of a sudden it starts running backwards, someone would think, oh, well, he's using the solar panels right now. But no, he's not really. He's got that thing flipped upside down. So you could kind of play a game that way, I guess. I mean, the utility would tell me more. That just popped into my pea brain this morning. I was wondering if that actually happens. So if someone knows about that, please sound in on the chat room. But to me, that would seem like you could also play that in that they might think, oh, well, now you got to remember out there at the Johnson's house, they got the solar panels. Okay, no problem. So it wouldn't flag. They wouldn't send someone out and think there was a problem.
Yeah. So again, meter powers up, right? Even upside down.
Yes.
But why is the meter turning backwards? If you think about it, if you flip that meter upside down, vectorially, I've got a positive direction flow for A, and I've got a negative direction flow for B to get that 240 volts I need to power up the site. Now, if I flip the meter around, it's the opposite direction. A is going negative, B is going positive. And that's why your meter's turning backwards.
That's right. Sweet.
Right.
Yep.
So if anyone can answer me about could this meter ever be misinterpreted as a renewable site, I would like to know, because that
Yes.
would be an interesting data point.
And if anyone's had any issues with a resi customer that's got solar panels, let us know about that too. I didn't know. It seemed like an example that might happen to me, but maybe not. I don't know. Or maybe they're getting away with it and nobody knows because they're thinking they're using solar panels. I don't know.
Yeah. Okay, so that wraps up for this one on the 2S meter. Now we're going to switch over to a 9S meter, where, if you remember, when we're talking about the AMI meters cannot detect anything on the transformer. If they did something on the transformer, the AMI meter would not detect that. So we're going to show that example here in a second.
Okay. Oh, CT10, it's right there.
Yep.
Okay. Let's roll. So should I take my gloves and hat and everything off? My Bandits Max. That's right. Just testing the CTs, right?
Yeah.
Cool.
If you guys will give us just a second while we rearrange webcams. I don't know if you've tried to buy webcams during this COVID thing, but it's tough.
Not only that, I am so. Oh no, I'm not gonna say anything. I'll jinx it for the other one. John Bullock already got me one time, and earlier there's wires running everywhere, and I definitely tripped earlier. I got the stink eye from Jared. See.
So what John plans on doing is he's going to run just a normal test on a 4-wire Y. And then we're going to see how that looks. And then we're going to try to simulate what happens if at that same site, let's say a month later, the guy sees the meter technician out there and says, oh, well, we're good. Goes out to the transformer, gets inside the transformer, and then starts messing with the CT. Let's see what it does.
What she look like? What she look like?
Let's get a little bit closer.
Okey-doke. Perfect. Sweet. Okay, so we're just going to run a. Yeah.
Yeah, sorry, you start. Be helpful to turn it on, wouldn't it?
Yeah, that'd be good. I don't get Mullins often, so it's always fun when I do. Let's turn the bench on first. That would help. Nice. Okay, so you can see here we've got the our 9S meter over here. It's fired up because you can see the red above it. So that one's hot. So what we're going to do is we're going to run a CT test. You can see over here we've got our 3 CTs and we've got our red flexes out there. So we're going to run a CT test, a ratio test on those 3 CTs. Okay. You've seen these once or twice before with us. So it's going to go through A phase, then B phase, then C phase. Since we have 3 flexes up there, it'll run all 3 phases. We don't have to move anything. So we've got 3 up there. So we got a pass on A. We got the measured ratio is 201.58 to 5, and so nameplate's 200 to 5. So we have an error of, you can see there, 0.79%, and then it's 202.08 on B phase for an error of 1.04. And C phase is, survey says, 203. So we got 1.5 on that. So we got all of them passed according to what we had set up as the pass or fail for the CTs for this utility company. So all of them passed right there. We got the green pass. But now it's been months later and someone goes out to test, and here are the results they get, because I'm going to come over here on C phase and I'm going to run this wire through here and I'm going to connect it. So what I'm going to do is I'm just going to take this green ground wire and I'm going to run it through here. Let's see if I can't get 4 turns through here. There's 1, 2.
Just in case the audience was wondering, those white cables are actually supposed to be there.
Yeah. get tight.
So as John's going through and wrapping this through the CT, you can see how easy this really is, right? And it doesn't take it's not a very expensive method
No.
to do. So what have we just done right here? We wrapped. Well, let's see our test result. Then we'll talk about why.
There you go. Okay. So, you know how the Powermetrix works here. I can the gold box around C phase. I can just retest C phase by hitting retest. So let's just retest C phase and see the difference right here. Oops. So we went from 1.5% to 7.5%. So that's 6% that we have increased our losses by right here, right? So our ratio here is 6% worse than it was before, and now it's giving us a fail right here. So if you came back months later and checked this site and tested it after that first one, you compare results from before with the results now and go, whoa, you know, for this site, you know, everything's stored on MeterSat Manager, so you could compare your test results from the last trip out to the test results now, and you'd look at it and go, I got a problem on C phase.
Yeah, notice this is a pretty balanced load. We put about 2.5 amps in the secondary. So what's the secondary current on the C phase?
The secondary current on C phase now is 2.35.
2.35. So you've dropped about 0.2 amps or so.
Yep.
Just by putting a cheap wire through the CT. Now what does that mean? The ratio goes up, and therefore the secondary current goes down, so the customer is paying less on that particular phase.
Yep.
It's paying less kW because we're measuring less secondary current to meter. Now if you went out there and did a test, right now it looks like a bad CT, right?
Yep.
So hopefully you would open that cabinet up by that point and see that there's a wire in between
That's right.
that CT. And the important thing to understand is that because this is such a small drop in secondary current, meters would never detect this. A tamper alarm would never detect this.
Yep.
Because it just looks like a small drop in load, which is extremely normal throughout the day. It would never detect it.
That's right. Alarms don't go off. We don't send the crews out, and the theft and tampering just continues.
There was a customer who asked, why did we insert the loop 4 times? Just to make it look worse.
Yeah, that's right. Yeah, that was a good question. We did it 3. I did it 3 the first time, and Chris said, try 4 and see what that did. And so, you know, it did step up. It stepped up and got worse. So it definitely got worse. It was like, if I remember right, it was 207,
Yeah.
right? It went up to 207 for my measured ratio with 3 turns, and went up to 214 with 4 turns. So no telling if I could get about 5 or 6 turns in there. Yeah, it definitely would affect it a lot. So you can see here that on C phase right here, they're getting away with it, and we would run our test. The equipment would tell you I got a problem on C phase, and that's where we start our investigation and become our forensics guys like we all are, and we go out there and we would find this.
Yeah, so if we think about this, you know, right now this CT has 200 turns, right, through the CT. So as I add more turns, let's say I add 4 more turns, that drops the secondary current down. So mathematically, that's why you're seeing what you're seeing.
Yep. Just go back over here.
No, probably just stay there.
Oh, still here? Is that cool?
Wrap it up.
Oh, sorry. Yeah, that's what I was going to say for the wrap up. I didn't. You just don't realize how good Jared is sometimes. He's got cameras everywhere. So, okay, there is one. Okay. They're everywhere in here. There's one here. So y'all don't know there's one back here. So anyway, once again, we really appreciate you guys tuning in. Hopefully, every time we talk about tampering, there's tons of everybody's got their stories, and hopefully you've seen where the equipment can help you. But really, you need all of your skills. You need sight to be looked. You need to think about it a little bit. Because not all of it is going to be detected by the equipment. So a lot of it is going to be visual. A lot of it is going to be what you're going to see. But there are going to be things with the equipment. Don't rule out tampering or theft, I guess is what I'm saying. So if you look at that, Chris made a good point earlier. Someone just saying, that CT's starting to go bad. No, you might want to go do a little investigating and check it out because, it's costing the company money, and you could find something like that. And you could be the hero like that Jesus guy was at CFE. They brought him in. I thought they were going to carry him on all over the deal on their shoulders. So, because that was tons of money. So, anyway, we just hopefully we're giving you some more tools and some things to think about when you're out there in the field. Don't forget, Tuesday is going to be effects of power quality, and Thursday is going to be that Q&A forum. Please send in questions ahead of time so we can prepare for them. Okay, so if you'll send us in some good questions ahead of time, you'll have everybody up there. You'll have a cross section of Powermetrix up there, so someone on there will be able to answer your question. Okay. So with that, I'll say God bless. Y'all be safe out there. Make it home safe. All right, and we will see you next week.